Okay, so picking up right where we left off, I've imported a couple more images from an external folder, so I just dragged and dropped them from another folder. And what we're going to do is, in this video, when a block gets destroyed, we're going to have a little explosion appear. It's going to be a particle system. And then, based on random chance, a power-up will show up. This power-up will increase the size of the paddle, and this power-up will increase the speed of the paddle. So let's get right into it. We're just going to quickly create the particle system. That alone could be an entire video. So if you want to pause the video and change the settings, that's fine. So go up to Object, Game Object, Create Particle System. Just going to rename this. Boom. Gonna rotate it on the X axis. The duration is going to be really short, like 0.25. We're going to get rid of looping at the last second. We need to see what the explosion looks like though as we're developing it. Start size should be small, like 0.15. Start lifetime should also be really short, like 0.3. Emission needs to be much higher, like 250. For shape, we want to shrink the radius. That way everything is coming out from a smaller area. So just grab one of the dots, oops, and just pull it in. And we also want size of a lifetime. We're going to have the particles shrink so they disappear when they're much smaller. So just going to add a key and then move the last dot down. The reason why we added this key is so that there's no shrinkage until you get towards the end. And then we can also make the color of a lifetime change. Similarly, we don't want to have, in this case, we're not going to change the color so much as transparency. So if you click anywhere up here, okay, what you've done is you created another keyframe. So if you make a change here, this here will not change. So now we can click on this one, bring the alpha down really low, and so now the particles are both getting smaller and becoming transparent. So we'll just quickly run that, see how that looks. That looks good. We now need to get rid of the looping, and we'll actually make that start size just a little bit smaller. And we will tweak the rate up a little bit too, to adjust for the fact that the particles are smaller. And there, that quickly you've created a little burst. Now we take that, drag and drop it into our asset area, and is now known as a prefab. It can now be instantiated. It can be created on demand in real time while the game is running. So now let's make our power-ups. So let's drag and drop one of them into the scene. And let's just change the name a little bit. Let's get rid of the spaces. It needs physics 2D, rigid body, because we're going to use gravity. That way we don't have to code it. It'll just automatically drop as soon as it gets instantiated. Let's give it a linear drag of like 3.5, because if you don't give it linear drag, it's gonna its speed will increase, just like when the object is really affected by gravity. You drop an object and it speeds up how quickly it's falling. So by linear drag, you slow it down. We're also going to freeze the rotation. That way when it hits something, it doesn't spin around. And then we're also going to do another physics 2D, and we're going to do box collider, and we're going to make it a trigger. So Basically, it instantiates when a block is destroyed, at least it's going to, doesn't yet. It automatically falls because it has gravity, and because it has a box collider, it has the ability to detect collisions. Now what we're going to do is we're going to take that, we're going to copy it, and we're going to paste it, and now we're going to rename it from Powerup Size to Powerup Speed. Click on Speed, and now we just use the other Powerup sprite. So you can see how very quickly you can really reuse an object that you've created and repurpose it. Now what we can do is these two will look different, and now you can base functionality on the object name, or if you want to use a tag you can do that. I have another video demonstrating how to use tags. In this case we'll just use Powerup, well, we'll use object name because there's only two. Tags really come in handy when you have like dozens and dozens of objects and you don't want to have to check for all the different names. You could just check for a similar tag. So let's now drag and drop those into our asset area, and we've created those prefabs. Okay, so we now have an explosion, and we have two objects that can be instantiated when the block explodes. So now we need to put in the code that instantiates the explosion, and we need to put in the code that randomly determines if an object is going to be spawned. So how are we going to do that? Well, right now there's already a code, there's already a script for destroying the block, and the code is right here, the on collision enter 2D. And remember, it's on collision enter because the block is solid. That's why it's not on trigger. We're going to use on trigger in a minute. So when the block gets destroyed, we want to instantiate the new explosion prefab we made. So public transform, we'll call it boom obj. You don't have to, but I try to append the letters obj to object variables. Basically, I want to remind myself that when I'm typing and the name comes up in the suggested list, the prefill list, by seeing the obj, I know that I'm looking at an object. Don't have to do it, that's just the naming convention I like. So by saving that, this script is attached to all the bricks. So what's going to happen is all the bricks will now have this new variable. So let's just move this bull out from in between the bricks, that way I can highlight all these much easier. So like if you click on this one, see it says boom object, boom object, boom object. So click on the top one, hold shift, click on the bottom one, drag and drop the prefab, and you can actually assign it to every single object that's highlighted at the same time, because they all have that common variable, because they all have the same script attached. So just like that, all the bricks are now aware of the explosion. Well, we also want the bricks to be aware of the power-ups as well, so they can instantiate those. So public transform, and we'll call this power up speed, and again obj. Totally optional, but I like to do that so I remind myself what I'm looking at. So power up speed obj, power up size obj. Save that. And once again, if you click on one of the bricks, you'll see that they're there. So highlight the whole group again, and power up size goes to power up size, power up speed goes to power up speed. Now all the bricks are aware of the explosion, all the bricks are aware of the two power-ups. Now to instantiate them. So we already have the collision detected. We already destroyed the block. This is therefore where we would instantiate some other things. So first, instantiate the boom object. And as I've said before, when you use the instantiate command, there are 3 arguments. What is being instantiated? Well, the boom object is going to be instantiated. Where is it being instantiated? Well, we want it to be instantiated at the position of the object the script is attached to, which is the brick, so transform.position, and we want to use the object's own rotation. So what's being instantiated? Boom object. Where is it being instantiated? Transform.position. What rotation is being used? Boom object.rotation. Save that. So now this will actually give us the instantiation of the explosion, so let's run it with that. There we go, just like that, you have your explosion. Now, we want to be able to instantiate power-ups, but you really don't want to power up every single time, and you don't want the same power-up. You have multiple power-ups. So let's create a new variable. Public int which power up. So in the collision area, we're going to determine if a power-up shows up, if so, which one, by using just one variable. Because what we're going to do is we're going to look for a range of numbers, say 1 through 10. If number 1 or number 2 shows up, 1 will instantiate one power-up, number 2 will instantiate another power-up, but 3 through 10 will instantiate nothing. So by using a single variable, you're able to both determine likelihood or chance of an instantiation and how often it instantiates. And so you just keep moving that upper number higher. If you find out that it's instantiating too many power-ups, we'll make it 1 through 15 or 1 through 20 or 1 through 25. And so that way you can, with precision, get that random chance that you want. So in the collision, if, oops, actually, sorry, before we do if, we need to set the value. So which power-up equals random dot range, and for demonstrative purposes we're going to use a very small range because if we want to make sure that it's working, so we have to have it occur more often than what we'd really want in the real game. So let's do 1,6. Now, according to Unity, these numbers are inclusive, and that is that the random range, the numbers will have 1 and 6, not just between them. However, in my experience, this upper number never ever shows up. Maybe it's a glitch, maybe it's a mistake in the documentation, but I never see this top number actually be a result of the random range. So be mindful of that. You might actually have to bump this number 1 higher than what you really want it to be. You just have to check that yourself to see if that top number is coming up, but it's never for me. So if which power up, now we don't care if the power up number is, like we said, the upper numbers will be no instantiation. So if it's a higher number, we don't have to check for it because we don't want anything to happen. It's only in the lower numbers. So if which power up equals 1, then we have this new section. And we're going to do another instantiate. So instantiate, this time we're going to instantiate power up will do size. And it will also be at transform dot position, and it will be at power up size object dot rotation. And now what we'll do is we'll rinse and repeat for the number 2, and that will be power up speed. So every time there's a collision with a block, a random number is generated between 1 and 5. Again, it says 6, but I don't think it actually does the top number. If the number is 1, instantiate this. If the number is 2, instantiate this. If it's 3, 4, or 5, you do nothing. So now you've stacked the deck against these 2 instantiations. This is a 1 in 5 chance, this is a 1 in 5 chance, and there's a 3 in 5 chance of no instantiation at all. So actually this should now work. So we should now get our explosion. We have a 2 out of 5 chance of either one of these instantiating, so it should happen fairly frequently, but nothing happens yet when the paddle collides. So this one, oops, got caught in the corner. Like I said, we have to do a little coding to really take care of that corner, but that's just kind of a more of a detailed programming session. So far this is actually kind of low, but then again, that's the nature of random chance. But then we had 2 in a row, so. So mainly what happens is when it hits the wall, it loses its when it hits the ceiling, excuse me, it loses its lateral movement. It goes straight, and so that's why we get in these odd physics. Like now, it's just going to keep going back and forth too. Okay, so we did see both power-ups. This one didn't show up as much as this one, but again, that's just random chance. So, last thing we need to do is we now need to detect a collision for the paddle and the power-ups. And what we need to do is we detect a collision, and then we actually have to make a change to the paddle based on the power-up. This one will change the size of the paddle, this one will change the speed of the paddle. So to do that, we need to go to paddle control, and we need to check for collision. So outside of start, outside of update, void on trigger enter 2D collider 2D other. So if this object is involved with a trigger type of collision, a trigger overlap, then we need something to happen. So what we're going to do is we're going to check that other name. So if other dot game object dot name equals and it is power up size or power up speed. So power up size, but because it's a prefab, the word clone in parentheses will be appended to it when it gets instantiated. So if the other object that it collides with is power up size, then get component. Remember, this is attached to the paddle, so if I do get component, I'm changing the paddle. So get component transform, local scale, and we're going to change x and y. So vector 2, x will become 3, it starts off as 2, and y is going to stay as 0.3. And you need to put in the letter F because this is a decimal. Now, that one's easy. What's a little bit more difficult, but still fairly easy, is the velocity. Because right now, the velocity uses constants. We'll have to change that so it uses variables. So let's just see if this works before we dive into that. So if I pick up a size 1, I suppose since this is testing, I could just change how often the size shows up. That's speed, not size. So that's not what I want. There we go. Boom, and it worked. The size increased. You can see the new larger paddle does indeed have collisions for that new extended size. Okay, so now for speed. So what we need is a new variable, public. Let's do this. Well, we'll do as an int. You might actually want to use a float so you can use a decimal, but we'll just do int. So public int, and we'll just call it xval. And it will start off as 0. Now, what we now need to do is we don't want we need to modify this, okay, based on, we need to modify these based on whether or not you've picked up a power-up, which we're going to do in a moment. So what we can do is, rather than really breaking this, we'll just modify it. So, alright, we'll just do minus xval. So what we can do is x velocity is going to be, say, like the number 1. So -5 minus 1 is -6. That means it's going to move faster. Here we do plus xval. So we didn't have to break this quite as much as I thought. Okay, so now I can copy and paste this, although we do have to make some substantial changes. So if other game object.name is power up speed, then this all changes. This is where we just change the xval, sorry. So we'll just change x velocity is equal to 1. So what happens is, if you grab the speed power up, this variable is set to 1. We originally set it to 0. So when it's 0, it makes no modification. When it's 1, this becomes a -6 and this becomes a +6. For demonstrative purposes, actually, let's move that up to 3, just so you can really see the difference in speed. See, much faster now. So if we restart it, slower. Now, right now the power-ups are not being destroyed. We haven't put that in yet. So let's change this to 6. Let's see if it... You can see it's much, much faster now. So actually that might even be more appropriate for the game to have it move that fast. And now, I should have just grabbed the length power up. Alright, so they're working. Now we just need to have the power-ups get destroyed when they're collided with. And to do that, we'll actually just create a new script. Create C# self-destroy, and you just click on the prefab, drag and drop the script, click on the other prefab, drag and drop the script, open up self-destroy, and in this we'll simply say we'll also do the on trigger enter just like on the paddle. So on trigger enter 2D collider 2D other, and we'll just check to make sure it's the paddle. And so this should check to see if other dot game object dot name equals paddle. If it does, then destroy game object. And just like in the brick section, where you instantiate this explosion, you could create a new prefab that maybe looks more like a glow, and that way when you touch the power-up, it doesn't automatically it doesn't explode and make it look like you're damaging the paddle. You want it to look more like a glow, like a power-up. Something a little more soft rather than harsh. Okay, so there's the size, and it made it bigger. Next size won't, and it did disappear. Run it one more time. And so really after this, the only thing that's left is adding a score. Well, two things are left. One, we want to clear up that issue where if it hits the ceiling and actually the bricks as well, it loses its horizontal momentum. It just moves vertically straight up and down. So we want to fix that. We want to add score, and there we go. You know, little things like that we need to clear up. But yep, the power-ups are now getting destroyed. You are now getting the power, and so probably just one more video where we add the score, do a more tightening up of the physics, and give you a limited amount of the bullets.